appreciate the opportunity to be here. Again, as Xavier mentioned, my name is Miguel Acosta, Chief of Autonomous Vehicles here at California Motor Vehicles in the United States. And over here at Motor Vehicles, we oversee the testing and deployment of autonomous vehicles in the state of California. I'll get into a little bit about how we define autonomous vehicles here in California, and I'll walk us through our regulatory framework, which has been in place now for a little over a decade. So we have a lot of experience with the testing of this technology on public roads. And then I will share about what our future plans are and how we continue to evolve our rulemaking to account for this evolving technology. So Xavier, I think you mentioned, if participants want to drop something in the chat or a question in the chat, Xavier, you can help me with that, monitor those questions and queue them up for me, because I may not see everybody. So appreciate it. I'm just going to walk us through a overview of our regulatory framework here in the state of California. And, I think a good place to start here is to describe the state's role in regulating autonomous vehicles here in the United States and the federal government's role, in the United States. So at the federal level, the federal government, through the National Highway Traffic Safety Administration, it's an organization, we use a lot of acronyms here, NHTSA. They're responsible for ensuring the safety of vehicles, and they do this through the promulgation of federal motor vehicle safety standards. So they regulate the equipment, the safety of the equipment of the vehicles at the federal level. And state governments, like in the state of California and motor vehicles, in contrast, we're responsible for ensuring the safe operation of vehicle on public roads. And we do this through the California Vehicle Code. Of course, there's vehicle codes in many other states, but we do this through licensing and registering vehicles. So again, it's the federal government's role overseeing the safety of vehicles, equipment of vehicles. And here at the state level, we're dealing with the operation, the rules of the road, the licensing of drivers, the registering of vehicles. So really, those are the two levels of government kind of work in concert. And this is the approach that we have here in the United States. And another good place to start is, I know probably many of you on this call have seen this, but we have since codified this in our vehicle code. This is actually California law now, that we are adopting the Society of Automotive Engineers. This is SAE, levels of driving automation. Okay, but I think it's a good place to start because, we need to understand and define the terms and understand what we mean by an autonomous vehicle. Okay, so in the state of California, we define an autonomous vehicle as one that's capable of performing the entire dynamic driving task without any intervention of a human driver, and this would be levels 3 through 5. Now, of course, we know that level 5 at this point is aspirational, and this is, at some point in the future, ADS systems will be able to perform at level 5. But really, an autonomous vehicle here in the state, again, we're focusing on level 3 and level 4. Okay, so that line of demarcation is very important, because when we're talking about SAE level 2 or advanced driver assistance systems, these are not autonomous vehicles. These are not currently regulated by the state of California in our program. And again, at level 2, again, the distinction being that at level 2, the human driver is still fully responsible for that dynamic driving task. Now, there are features, as many of you are aware, there are features that are very capable of performing many components of that dynamic driving task. But still at level 2, the really key factor is the human driver is responsible and in control of monitoring the driving environment. So again, I think it's very important to understand the distinctions and what is an autonomous vehicle and what is not. Okay, so here's again a brief overview, high-level overview of our entire program. Regulatory timeline, like I mentioned, here in the state of California, it's been over a decade that we've had rules in place governing the safe operation of autonomous vehicles on public roads. So it all started back in 2012 when the California legislature authorized the Department of Motor Vehicles to regulate AV operations. So that was Senate bill. We have two houses in our legislature here in California. The Senate passed a bill, 1298, back in 2012, authorizing the Department of Motor Vehicles to move forward with regulating this new technology, this emerging technology. And in 2014, the department issued our very first set of regulations. So at that point, the regulations only allowed for testing with a safety driver, only testing with a safety driver at that point. And then in 2018, we issued a second set of regulations, which brought in two more permits. The two additional permits that we brought in were, so we had testing with a safety driver, but we also brought in driverless testing, what we call driverless testing, and that is where a manufacturer of the technology can test the technology without the presence of a safety driver in the vehicle, okay? And we'll get into the specifics of all of these permits in just a little bit. And the third level of permit that we ushered in 2018 was something that we call deployment. So here in California, the distinction with deployment is when a manufacturer is ready to receive compensation for the use of the autonomous technology. So that could be a couple of things, right? So it could be selling the vehicle to members of the public. We actually have one manufacturer that's doing that currently. And then the other is if they want to receive compensation for providing services, for example, ride-hail services. As Xavier mentioned at the top of the presentation, Waymo is giving robotaxi rides for compensation. They have a deployment authorization. If a company wants to deliver goods for compensation, we have a company doing that. That is also deployment. So if a company is testing, though, they are not authorized to receive compensation. And we set that line of demarcation in place so that companies can focus on testing the technology, ensuring that the technology is ready and able to move into commercial operations. And so when they're able to do so, they can cross over, so to speak, into that commercial realm. And that is the third level of permits. That's deployment. So in 2019, we had another set of regulations, and that ushered in light-duty delivery vehicles. So we allowed for vehicles that wanted to deliver goods to members of the public in 2019. So as we've seen, that's a long time ago in this technology, and there are many other use cases that have started to emerge. One of those use cases that has emerged that we have been actively looking at is autonomous trucking. So heavy-duty vehicles in states like Texas, Arizona, New Mexico. There are companies right now that are testing this use case with autonomous trucks. Here in the state of California, we currently have a prohibition on the vehicle weight rating, which prohibits these trucks from testing autonomous technology, not only testing, but deploying this autonomous technology. So we have been creating, listening sessions and workshops. So we see here on the slide, back in 2023, we had some public workshops, and we wanted to hear from the entire stakeholder community about how this could work. And in addition, we also facilitated other workshops with first responders and law enforcement to get some additional ideas about how we can enhance those interactions with autonomous vehicles. And many of you may have seen in August of last year, we released a draft set of regulations to the stakeholder community. And this was an informal set of regulations. And what we were seeking input to see what kind of ideas we could put forth in a formal rulemaking package. And that was in August of last year. So you can see in this process, our regulatory process is really about engaging all stakeholders. So that would be industry, academia, safety advocates, labor. Really, the regulatory process here in the state of California brings together all stakeholders who can provide input into this regulatory process. And so that's where we are right now. And I'll get into a little bit about where we are in moving forward in the future. But again, here on the screen, we have 30 manufacturers who are authorized to test with a safety driver. We have started to see a little contraction in the industry. At one point, at the height of the activity here in California, there were as many as 70 manufacturers testing here in the state of California. Right now, there are 30. And so there's been some contraction within the industry. And then that's the first level of permit, testing with a safety driver. The majority of manufacturers are in that particular permit. The second level of permit is testing without a safety driver. There are 6 manufacturers that are currently authorized to test without a safety driver in the vehicle. And then we have 3 manufacturers who are approved to deploy autonomous vehicles on public roads. And so here are some of our numbers. We see the total number of vehicles that we have active in the fleet here in the state of California that we're monitoring. And then we have active test drivers here. In addition to registering and licensing the vehicles and the safety drivers, you can go right now to our website, and I encourage you to do this, www.dmv.ca.gov, and we have on our website all of the testing data associated with the AVs operating on public roads since the inception of the program back in 2014. And so on the screen here, you see all of the crashes, the collisions that we have. You can actually go on our website and download and take a look at all of those particular crash reports. In addition, since the inception of the program, AVs, autonomous vehicles, have driven over 31 million autonomous test miles on public roads here in the state of California. And you can go and see all of the disengagement reports associated with that testing. So I encourage you to do that. There's a lot of information there, but we wanted to make that publicly available so that anybody can access that information, and that really has increased transparency within the industry. Okay, so the majority of companies are testing right now in what we would call in California the Bay Area region. This is the home to Silicon Valley. Of course, Xavier, when he mentioned the trip that the team took to San Francisco is part of the Bay Area. It's in Northern California. The majority of companies are based in that Northern California Bay Area region right now. There are many of those companies have headquarter operations there. But what we started to see are companies starting to move into the southern part of the state, into Southern California. Most notably, Waymo has expanded into Santa Monica, California, and Los Angeles, California. And in addition, we have Mercedes-Benz is offering their Drive Pilot feature, which I'll get into in just a bit. And that is on public highways from San Diego all up into Northern California. So again, here are the 6 manufacturers that are authorized to test without a safety driver. Of course, Waymo being on the top. There's a company called Nuro, and Nuro has this little delivery robot that we see here on the screen. It's called the R3 robot. It's a purpose-built, lower speed vehicle. It can go up to 45 miles per hour, and it does not have any controls for steering wheel or braking. In fact, a person really can't be in the vehicle. It's purpose-built for delivery. And so here on the Nuro vehicle, these hatches will open up and they have goods inside, and they'll show up and they'll drop off your groceries for you. So that's Nuro. They're based in Mountain View, California. Xavier mentioned the trip to China. And so we have several companies here that are authorized to test without a safety driver here in California. We have AutoX, we have Apollo, and we have WeRide. Those I saw on your screen for your trip, your summer trip. Those companies, WeRide is based in San Jose, California. AutoX as well in San Jose, California. And Apollo, also known as Baidu, is operating out of Sunnyvale, California. They also have an operational design domain that allows them to test in the city of San Francisco. And the final company that has a permit to test without a safety driver is a company called Zoox. And Zoox is emerging. You may have seen some press on Zoox, and I'll show you what their robotaxi looks like in a slide or two. But they're also able to test without a safety driver. So the three companies that have authorization to deploy, as I mentioned, deployment is the authorization to receive compensation. So these companies can actually either sell their autonomous technology, or they can receive compensation for delivery or robotaxi services, okay? So three companies are Nuro, as I mentioned, the little delivery robot vehicle here. And then, of course, Waymo. Waymo has the Jaguar I-Pace that they are using. And then Mercedes-Benz. So Mercedes-Benz, this is the S-Class, the Maybach vehicle. Mercedes-Benz is the only OEM currently in the United States that is selling an autonomous vehicle to members of the public. Mercedes-Benz has developed a level 3 driving feature called Drive Pilot, which allows the vehicle to operate on public highways at lower speeds during traffic jam or traffic jam assist type features. So think of bumper to bumper traffic up to speeds 30 miles per hour. There's a lead vehicle. The Mercedes-Benz level 3 feature will do all of the driving task for the vehicle in that particular operational design domain. Of course, the human driver is then considered the fallback ready user if there is a need to or request to take over. But again, Mercedes-Benz is the only OEM at this time that is authorized to sell an autonomous vehicles to members of the public. Okay, so again, the majority of companies are here in this particular permit, testing with a safety driver, okay? And so this is the original permit back in 2014 that we came up with following rules associated with rules governing not only registration of the vehicles, but also the safety drivers. The safety drivers represent a critical piece to ensuring the safe testing of these vehicles on public roads. And so we have very stringent test driver requirements. So again, these vehicles at the onset, before they can actually even be placed on public roads, have to meet federal motor vehicle safety standards or have an approved exemption from the United States Department of Transportation. If you recall on the previous slides that I presented, the federal government, again, their role is to promulgate federal motor vehicle safety standards, the equipment of vehicles, any vehicle that is sold in the United States. An original equipment manufacturer has to certify that that vehicle meets those standards. And so these autonomous vehicles that are testing on public roads, again, these vehicles have to meet those federal standards before they can receive registration. So again, the test driver requirements, very stringent requirements here because the test drivers are very critical in ensuring the safe operation of these vehicles while they're being tested. So here at the department level, we ensure that every one of those drivers has what we would call a clean driving record, okay? So what does that mean? That means that these test drivers can't have a driving under the influence. We call it DUI, driving under the influence in the last 10 years on their driving record. They cannot be an at-fault driver in a collision that resulted in injuries. Let's say that they were involved in a crash and there was an injury. They cannot be a safety driver if they have that on their driving record. In addition, they have to be able to complete a test driver training program that the manufacturer describes. So every single manufacturer, when they apply to the department, they have to describe the test driver training program. And that includes not only classroom training, but it also includes on-road training on a closed course prior to even getting out onto the road. Okay, so every test driver has to be an employee, contractor, or designee of the actual autonomous vehicle manufacturer. Another component is we have a program here in the state of California called the Employee Pull Notice Program. And what that does is that all of these drivers are enrolled into an automated system that tracks every one of their driver license records. And so what that does is if a driver, even if they're not working, is involved in some kind of traffic violation and receives a citation, it will be reported to this system, and then we can see those particular triggers. So we're always monitoring all of the safety drivers. So the company, the manufacturers themselves are responsible for monitoring these drivers, and the department on our side, we're also monitoring these drivers to ensure that these safety drivers have the clean driving records and they're able to perform that task. Something other unique, as I mentioned on our website, we have posted all of the collision reports, okay? So a manufacturer has to report any collision that occurs on public roads, whether it's in conventional mode or an autonomous mode. Let's say that a autonomous vehicle test driver has disengaged and is driving in the conventional mode during a test route, and there's a crash. Any collision has to be reported to the DMV within 10 days. Otherwise, there's a violation of the permit. And so again, if you go out to our website, as I mentioned earlier, you can see all of those particular crash reports from the beginning of the program. The other data that we collect is something called an annual report of disengagements. So a disengagement occurs when the test driver has to take over control of from the autonomous system in order to ensure the safe operation of that vehicle on public roads. So anytime that safety driver takes over or there's a disengagement, the manufacturer has to provide that information in an annual report to the department. So you will see, again, if you go out to our website, maybe some of you are doing that right now, you can go and see the latest data that we've had from 2024. You can see all of the companies that have posted disengagement data. Okay, so the testing permit's valid for 2 years. And as I mentioned previously, we have some prohibitions in the program. Currently, right now, vehicles that weigh over 10,001 pounds gross vehicular weight rating cannot operate at higher levels of driving automation on public roads here in California. So again, think of the Class 8, the semi-trucks, box trucks, big delivery trucks. Those vehicles exceed the weight limit and are prohibited, but that is something that we are taking a look at currently right now. Again, motorcycles, we don't allow for the testing of autonomous motorcycles either. Okay, so that was the first level of permit. Here's the second level. This is testing without a safety driver. And of course, we have some examples here on the screen. We have the Waymo Jaguar I-Pace. Xavier mentioned. And many of you may have, if you've been to San Francisco, have seen this particular vehicle and maybe even taken a ride in this vehicle. Again, this is a Jaguar I-Pace vehicle. It is a vehicle that has manual controls, steering wheel, brakes, but it is also a fully level 4 automated driving system. And the other vehicle that you see here on the screen is what I mentioned from this company called Zoox, Z-O-O-X. And Zoox has developed a purpose-built robotaxi, and you see it right here, that actually has no manual controls at all. It is a fully level 4 autonomous system. And if you go inside the Zoox robotaxi, there's seating for people. They can go in here. So those are the types of vehicles that are being operated by manufacturers currently. So the second level of permit, testing without a safety driver. So many of the same requirements as testing with a safety driver apply, okay? I forgot to mention that one of the other components is that each one of these manufacturers has to be able to respond to a judgment in the amount of $5 million. So they have to carry insurance of up to $5 million, every one of the manufacturers. So that's the same case of testing with a safety driver, driverless, or deployment, okay? But here's some of the unique characteristics of testing without a safety driver. The first being is that there has to be a communication link with the remote operator. Okay, so if there's no safety driver behind the wheel, the manufacturer has to describe how they're going to be monitoring that autonomous vehicle while it's operating on the road. So there has to be a communication link between the ADS, between the driver here, the ADS driver, and the manufacturer. So the manufacturer has to describe what that communication link is and whether or not they're using a remote operator. I use the term remote operator because it can apply to a couple of different use cases that we have seen. There are some companies that use what we would call remote drivers. These would be people who can actually drive the autonomous vehicle from a remote location. The other type of remote operator that we have seen in the program is a remote operator that's known as a remote assistant. Now, a remote assistant does not have the ability to drive the vehicle. They can only provide guidance, comments, waypoints, and the autonomous vehicle, the ADS, is still responsible for the driving tasks, still has to make those decisions, and takes into consideration the guidance. So we have seen a couple of different remote operators. So when I say remote operators, I'm including both remote drivers and remote assistants. So you can imagine that there needs to be a process also to communicate the vehicle ownership and operator information to a law enforcement officer. Okay, so if you or I were pulled over by a law enforcement officer, the officer would ask for your license and your registration insurance information. Okay, well, when an officer pulls over an autonomous vehicle, there's no human driver in the quote unquote driver's seat. So there needs to be a process by which the manufacturers can display this information. And how do they go about doing that? Well, there is a document that we have placed into regulations, and this is now starting to be widely adopted, and it's called a law enforcement interaction plan. And basically what that plan describes is how our law enforcement officials going to be approaching the vehicle. How do they understand that the vehicle is in autonomous mode, or if it's disengaged, if it's stable, and how to actually receive the contact information of the remote operator. How are they going to connect with that remote operator? And where in the vehicle can they access insurance information and registration documentation? Okay, so that's all part of the law enforcement interaction plan. So again, testing without a driver, these vehicles have to meet the description of a level 4 SAE, level 4 or level 5 driving automated driving system. Okay, so it can't be level 3 because as we know in level 3, there's a fallback ready user. There's a human driver in the driver's seat in a level 3 feature. So all of the vehicles, all the systems that are testing without a safety driver are currently at SAE level 4. Okay, and as I mentioned with the testing program, the companies are not allowed to charge a fee or receive other compensation for providing rides to members of the public. One other thing that I'll mention, because we are a motor vehicle agency, we do licensing and we also do registration, is that we register every one of these vehicles and we mark all of these vehicles. So you'll see here, there's a license plate here, this license plate indicator. Of course, on the Zoox vehicle, this is a display plate, but they have license plates as well. When these vehicles are registered, what we do here at the DMV is we mark these vehicles in what we would call the vehicle registration master database as being autonomous vehicles. Okay, so what that does is that our law enforcement officers who are on the streets, who are patrolling, they have something in their vehicles called the California Law Enforcement Telecommunications System. It's called CLET system. And what they can do is they can actually key in license plates on the road in real time and see the disposition and information associated with every one of these vehicles. Now, if you look at this vehicle, you probably can tell that this is an autonomous vehicle, right? It has, it has a LiDAR, has the sensors all around it. But just by looking at the license plate, by keying in the license plate information, the law enforcement officer can see right away that this vehicle is marked autonomous, that is an autonomous test vehicle. And that is very important when they're doing traffic stops and they're trying to understand whether or not this vehicle is registered under the California program. Okay, so this is the third level of permit. This is deployment, okay? So we have 3 companies currently authorized to deploy, and we have some pictures of the vehicles. Of course, the Mercedes-Benz, very high-end vehicles here that have the Drive Pilot feature enabled into these vehicles. But again, we also see the Jaguar I-Pace with Waymo. And here's another view of the Neuro vehicle, okay? So you can see the size of the vehicle. You see this, the person here is standing next to the vehicle, and there's little cargo areas for delivery. And so again, this is a purpose-built level 4 vehicle, okay? So in deployment, what are some of the unique characteristics? So when the manufacturer applies to the department, they have to provide a full description of the operational design domain. Okay, as we know, the operational design domain is basically where the ADS can go and where it cannot go. These are the limitations associated with the ADS. Okay, so they could be a geolocation, a geographic location. It could be a roadway type, speed limits, weather limits. So the manufacturer is going to have to describe in deployment what is the operational design domain of that particular feature. So listing all those restrictions. And then also, more importantly, how will the vehicle respond when it is outside of that operational design domain? So if it reaches a limit, as we know in the level 4 features, when it reaches a limit of its operational design domain, the autonomous vehicle must come to what we would call a minimal risk condition. It must be able to recognize that it is outside of its operational design domain, and it must achieve some minimal risk condition. Now, that could mean a variety of things. It could mean slowing down, stopping in lane, conducting a pullover, but the manufacturer is going to have to describe how the feature will do that. And that is a distinction between, again, we go back to the SAE designation levels, level 2 and level 3 and level 4. In level 3 and level 4, the ADS has to be able to recognize its operational design domain limitations and either signal in level 3 to the fallback ready user, like in the Mercedes-Benz vehicle, please take over. There's a situation where I'm outside of the operational design domain. In the case of Mercedes-Benz, there's a set amount of time to trigger that takeover. And if that fallback ready user, for example, is not available, let's say there's a medical condition, the person is not able to take over the driving task, then the ADS, the level 3 ADS, will put on the hazards, can call out for help, and do a pullover in lane. So that's just one example of a minimal risk condition. The other thing the manufacturer has to describe is a summary of the technology testing within the operational design domain. So the manufacturers have to describe all of the testing that they've done with a safety driver, maybe driverless testing. Of course, at level 3, there's no driverless testing, but what is the summary of the testing in the operational design domain? So the number of test miles they've driven, the testing methods, and then if there have been any collisions while operating in autonomous mode, the manufacturer has to describe all of the remediations associated with those particular crashes that occurred. The vehicles, like I said on the onset, have to be in compliance with federal motor vehicle safety standards. And in the case of Mercedes-Benz, so if vehicles are going to be sold to members of the public, there has to be what we would call a consumer end user education plan. So there has to be consumer protections in place such that the owner of the vehicle is properly trained to understand how to use the ADS feature. In the case of Mercedes-Benz, they have a training program that every single driver of the vehicle, the owner of the vehicle, has to go through before they can actually use that particular feature. And again, the law enforcement interaction plan, that is also a carryover from the driverless testing, but in deployment, they also have to, the manufacturer has to describe, again, how law enforcement will interact with that vehicle. So that was the current regulatory framework. And as I mentioned, as I'm standing here today, discussing this in April here of 2025, we're at a point where we're taking a look at the future and what that's going to be with the next regulatory framework. Because here in the state of California, we believe that we have created a framework that not only encourages the innovation, that supports the innovation, that supports the use cases that are perhaps one day going to reduce accidents, that are going to unlock mobility, that are going to enhance transportation on our roadways. Here in the state of California, we are actively supporting all of that innovation. At the same time, we have a regulatory framework that emphasizes and focuses, and its main focus is traffic safety. So again, it's that balance between supporting innovation and also traffic safety. So we have a framework in place that is evolving as the technology continues to evolve. And we've been doing a lot of work on this front. And I'll share with you a little bit of the work we're doing and what we're looking forward to in the very near future. Okay, and as I mentioned at the onset, heavy-duty autonomous vehicles. So we see here on the screen, you may have heard from some of these companies. These are just some of them. There's Waabi here, there's Aurora, there's Gatik. These are companies currently right now that are developing ADS features in these heavy-duty truck platforms. And so this is something that we're actively taking a look at. How do we fold these trucks into this light-duty framework that we have currently right now? The second component we're looking at as we move forward into the next regulatory framework is expanded data reporting. As many of you may have been following the space, back in 2021, 2022, we started to actually see level 4 driverless vehicles on the public roads. Now, as I mentioned at the top of the slide deck, in 2018, we issued a set of rules that allowed for driverless testing. Well, companies actually didn't start operating driverless testing or driverless technology until 2020, 2021, 2022. We started to see these vehicles emerge on the public roads. And we started to see some interesting incidents that occurred. Many of you may have seen these. They were widely reported in the public news media, where vehicles became immobilized, where they reached the edge of their operational design domains, and they had to reach out to their remote operators, and vehicles became quote unquote stuck on public roads. And so one of the things that we have seen is that we needed expanded data reporting so we could better understand these types of incidents. And as I mentioned in the presentation previously, we currently only require manufacturers to report crash data and disengagement data during testing. And the thought really behind that was that when a manufacturer moves into commercial deployment, they really are kind of ready to move into that commercial realm, and therefore they do not need to continue to report data to us as they did in testing. Well, what we found is that there are these incidents. We feel that we would like to better understand a lot more of these incidents and are looking to enhance our data reporting, not just in testing, but also in deployment. So that is something that in our next version of the regulatory framework, you're going to see enhanced data reporting, not only in testing, but also in deployment to account for many of these incidents that we are seeing on public roads. And the third kind of major point of our new regulatory package that will be forthcoming is something called the AV Notice of Non-Compliance. This is something that's very unique to California, and this was just signed into law by Governor Newsom last year. And it was a bill that was proposed by a legislator out of San Francisco. And, one of the challenges with a fully driverless system, there's no human driver. If you or I were pulled over by a law enforcement officer, they would ask for your license, your driver license, right? And let's say, for example, if I had committed a traffic violation, I ran a red light, or I didn't come to a complete stop, the ticket that I would receive would be issued to my driver license record. Okay, so every Californian who's driving on the road has a driver license record. And if there's a conviction in the courts, that particular citation, that particular conviction goes on the driver license record. Okay, but in ADS, the autonomous vehicle does not have a human driver. There's no driver license. And so one of the conundrums, if you will, was that how would a law enforcement officer issue a citation to an autonomous vehicle? Well, there just wasn't a mechanism. And so this new law is going to create a mechanism whereby a law enforcement now can issue a citation to the autonomous vehicle. Okay, and how this is going to work essentially is that the AV manufacturer is going to be issued the citation. And kind of some of the reasoning behind that is that the autonomous vehicle manufacturer is the one who's most capable of ensuring that any kind of remediation effort will be made if there is, let's say, for example, some kind of traffic violation. Because really any traffic violation that occurs, what we're looking for is to correct the driving behavior, whether that's for a human driver who has to go to traffic violator school or who receives a monetary penalty. What we're looking for is improvement in your driving behavior. So similarly, for an autonomous vehicle, who or what entity is most able to ensure that ADS improves? And that's the AV manufacturer. The AV manufacturer who can make software adjustments or hardware adjustments on the system. They're most able to address this. So the citation will go to the actual AV manufacturer. And the way the law is written here in the state of California now is that the manufacturer will have 72 hours from the time that they receive that citation. They have to be able to provide that to the Department of Motor Vehicles. So we would receive that citation, and then we would trigger a process where we would engage with the manufacturer, and we would engage with the manufacturer to ensure that driving behavior was corrected. And if the driving behavior was not corrected or they were not able to address it, then there would be some enforcement actions associated with that. So this is a very new process I'm sharing with you right now. And Xavier, if you invite me back next year, or we can kind of talk about the lessons learned from that, but that is a very new law, and there's going to be a lot of new policies associated with the enactment of that law here in the state of California, particularly associated with the citing of an autonomous vehicle that commits some kind of traffic violation. Okay, so we talked a little bit about the licensing, we talked about the registration, the requirements for the permit, but the legislature here in the state of California has also given the department broad authority to suspend or revoke a manufacturer. So there are very strong post-permitting controls here in the state of California. So the department can suspend or revoke a deployment permit or a driverless testing permit if the manufacturer's vehicles are determined not safe for the public's operations. Okay, so if there's some conduct by the autonomous vehicle on the public roads that poses some unreasonable risk to the public, the department can step in and suspend immediately the actual operations of that particular manufacturer. And since 2014, we have issued 3 orders of revocation and 13 orders of suspension to manufacturers. Now, this is a very important tool that we have, and it's something that we take, again, very seriously. The most recent one of these events occurred with General Motors Cruise due to a crash that occurred in San Francisco in 2023. And we immediately stepped in and immediately suspended the driverless testing and the deployment authorization for Cruise General Motors. And so again, that's just one example of the post-permitting controls that we have here in the state of California. Again, I went over quite a bit on this slide, the slide deck, but happy to talk about any kind of questions that anybody may have.
Thank you so much, Miguel. There are questions, of course, and I think it was very interesting. I think we can go through them, and maybe we can first take the written questions. But of course, at some point, if you want to open your mic and ask a question directly to Miguel, this is the idea as well. So Cormac is talking about especially the data reporting. You've been talking about that in the new regulation that will come this year or next year. Can you? I mean, we've seen that in China, they also have quite a lot of regulations, and there was very interesting article a few days ago about this black box approach. How would you say? I mean, what's the level of data sharing that you have, and what's the granularity, and what are you doing? Because there was another question also about what you do next with those data. To what extent do you use them for analysis?
Yeah, that's a great question. So really what we're looking for is really taking a look at the incidents. Let's say there's a particular incident that occurs on public roads that requires us to again, what we're looking for, as I mentioned on the slides, is there some kind of unreasonable risk to injury? Is there some kind of risk to traffic safety? And what is that? And so the data that we're collecting is really to inform that review, okay? So we're looking for specific data points to help us with the review of those particular incidents and whether or not we need to take enforcement measures, okay? So at the federal level, the data is used to determine whether or not they need to do a recall potentially on the autonomous vehicle, okay? But at the state level, we're taking a look at that particular data to see if we need to take enforcement action on a registration or the license of the actual manufacturer. And until the manufacturer can address a particular issue, now if they cannot address it, then they may need to be suspended for a period of time. And so again, that's what we're taking a look at. That's what we're using the data for. It's really to inform our review of particular incidents that occur on public roads.
Okay, and I'll give the floor to Cormac. So because this is the other way around, how city authorities should be sharing information like live data about city, like emergency responders. But Cormac, you wanted to
yeah, just to elaborate on that point, we've seen a lot of unfortunate events with first responders, and I did a freedom of information request to the fire department in California and asked them if they had on board live data that could be shared with operators, so the operators could avoid these areas, and that would go as well for roadworks and road closures. We've seen quite a dangerous event happen at the Chinese New Year's festival, where a robotaxi entered a road closure. Now, I would blame the city authorities rather than the operator for that event. And in China, we don't see these events because the city works hand in glove with the operator and shares that information. So events like this could not happen. So I'm wondering if the DMV could put more pressure on city authorities and mandate that they share the data. And again, with the priority communications, we've seen a lot of robo-taxis where they cut out in high traffic areas around stadiums and events. And again, those vehicles should be given priority communications so that sort of cutout does not happen and cause traffic snarl-ups. So I'm not so much worried about the operators not doing the right thing, but are our city authorities keeping up with developments? And how could the DMV encourage city authorities to be more proactive in this space?
No, that's a great question. I think it really varies from jurisdiction to jurisdiction. And as you mentioned, San Francisco, there's a lot of testing going on in San Francisco, so they have a lot of experience, right? And now we're starting to see robotaxis emerge into Los Angeles. Los Angeles is starting to gear up to that effect. There's also, as I mentioned in the new regulations, there is a new law, Cormac, in the state of California that is talking about requiring these jurisdictions to provide what I think you were describing as avoidance zones, okay? And so these would be situations where, let's say there is a emergency response situation and the city has to tell you call them operators, we call them autonomous vehicle manufacturers. The manufacturer would have to create an avoidance zone where the vehicles could not go in. And so that is actually a new law that's coming into play. And that is now going to be part of our updated regulations, where the manufacturer is going to have to receive that information from the local jurisdiction. And, the other AVs in that area would not be able to enter into that particular zone, so to speak. I think the challenge you're describing is that you have many jurisdictions that have varying degrees of experience with autonomous vehicles. And also, it's also a resource issue as well. But this is a challenge that I think we're all continuing to try to understand. But Xavier, invite me back. Maybe we'll give it an update, and Cormac will maybe pick that up when we implement some of these updated regulations.
That's brilliant. Thanks very much.
Yes, I will definitely invite you back. So Pierre has a question about remote driving. Is it something that you allow in California, especially in the deployment phase? How do you regulate this? Because this is quite different.
No, it is quite different. I think that the difficult thing is, I'll just state on the onset, there really are no set standards associated with what I will call teleoperations. Or remote driving. And I think that this is a challenge that I think that all of the different regulators, not only in the States here, but internationally, I really enjoy trying to listen to other regulators grapple with this particular challenge. But teleoperations, there currently are no set standards in terms of, let's say, latency, where the actual remote driver has to be located. And how these networks have to be constructed. Now, I know that there's guidance. I know that there's a lot of good work being done at this, but what I'm referring to is a standard that is going to be adopted in a large scale that regulators can access. Now, again, we are taking a look at different forms of guidance, and so I think that that's always important to take a look at. But I think one of the challenges that we see is, you could have a remote driver who may not even be located in the state of California. You could have a remote driver who's not even properly licensed to drive a vehicle that is manually driven by a human. And I think these are some of the challenges we're grappling with, that as we even bring in heavy duty trucks, you can imagine a heavy duty semi truck. There are rigorous requirements associated with those drivers. They have to take commercial driver license tests. And one of the things we're taking a look at, the remote drivers should at a minimum have those same requirements of a commercial driver who's operating these larger scale vehicles. And so again, these are challenges that I think as regulators we're grappling with. But I think from our perspective, we want to ensure the remote drivers are licensed similarly to a human driver, and that the manufacturer has to be able to provide the type of training. What is the training they're providing? In addition, from a remote driver perspective, what does your communications network look like, right? How are you providing redundancies across that communication channel? I think Cormac, you mentioned these large-scale events where the cellular network could be impacted. How is that going to impact remote driving? Frankly, I think that remote drivers, there's less AV manufacturers that are focusing on teleoperations, what we're seeing is more of them are focusing on remote assistance. So I think that's a long way of saying that we're still learning, but remote driving is one component for supporting these ADS systems.
Okay, thank you, Pierre. You wanted to elaborate on this?
Yes, thank you. Thank you very much, Xavier, and thank you, Miguel, for answering. One challenge we are facing, in fact, is regarding, I want to have your feedback on that, regarding public transport with autonomous shuttles. When you want to put a shuttle on a service, for example, you put it on point A to travel from point E, point B, point C, etc., and do something. There's something we call in France, there's a terminology in France that you need to drive this vehicle from its parking of the night to start in the morning. You need to drive it to the starting point. Either you have a personnel that can drive it manually, okay? Either you can do it autonomously from the parking to the starting point, or you can drive it remotely with a low speed, very low speed, to drive it from this point to the starting. And there's a question that we are discussing with the regulation to put it in place regarding this. Is this something that you have tackled? I'm not talking about full remote driving as you highlighted, which is very problematic. But for this part, did you tackle this, for example, in California?
So we allow for that particular use case, Pierre, and again, there are some manufacturers that have worked on that particular use case as you're mentioning, very low speed, remote driving kind of assistance at that point. Again, as I mentioned at my response to the question, there are no set standards yet. And I think that we all collectively in this space, industry, academia, regulators, we all need to, and we're continuing to do so. That's why these platforms, Xavier, these platforms are so great, because we need to continually discuss these, Pierre, because again, happy to share offline lessons learned we have seen here in California, but I think even at lower speeds, there's quite a bit of challenge associated with remote driving. Because if anybody have seen these teleoperations setups, it requires a great amount of visualization into the vehicle, number one, and it requires a robust set of redundancies. Okay, so you can imagine if you're trying to drive a vehicle and you have some sort of latency on the network, or your video feed starts cutting out, and it's nighttime. And even if you're operating at low speeds, let's say a vulnerable road user is driving by on a bicycle, right? So I think these are some of the challenges that I think we've seen. But happy to continue the discussion, Pierre, offline. If you have my email, we can continue to do so. But I think remote driving continues to be a challenge. But I think one of the things we're really trying to tackle that with is not just creating guidelines associated with how the manufacturer provides their description of the setups and their telecommunication systems, but how they're training those remote drivers. And also, how does the vehicle respond when there is a degradation in that network? So again, a challenge that we're continuing to face.
Yes, just for information, there's going to be a project. I mean, there is a project in Belgium, in the port of Antwerp, with using the technology that you also have in, not in California, but in Las Vegas, with VEI technology. So it's something to follow, and we'll see a bit in a very dense area with a lot of communication, because it's in between big ships and so on. So to see if the redundancy and the connection is good, but I know that's Dario, you wanted to say something?
Yeah, two quick remarks. So first thing about remote driving in Switzerland, for instance, that have published a quite extensive regulation about AVs, completely doesn't tackle remote driving at all. It's not allowed at all in Switzerland, which is quite interesting in terms of strategy. And second remark regarding the question from Pierre, I think this small use case you were mentioning of bringing the shuttle to the actual track from depot, that's, I think, a non-question, because it's actually due to a limitation we have today from the technology. But this technological limitation shouldn't be here in a few months or years from now. So I think this few kilometers that will be between the depot and the actual deployment won't be the first use case of this technology. I think there are other use cases where it's probably more important to have this kind of teledriving. I hope at least that technology will be able to tackle this kind of use cases.
Okay, thank you. So I go back to a question about shuttle, because you haven't talked about shuttles. You're mostly about robotaxi, delivery robots, and big trucks. However, the city of San Francisco, or the I don't know at what level, also tested shuttles. What's your opinion on those shuttles, and do you see that there will be a new test of new generation shuttles in California in the coming years?
Yeah, great question. You know, I should have mentioned this more, but really our framework focuses not specifically on the use case. We are really trying to create a framework for the technology, for the use of an ADS on multiple platforms. The platforms I kind of described in the presentation are just some of the use cases. We do have shuttle manufacturers in the program. Okay, there are companies called Beep is one of them. They're operating shuttles not only here in California, but also in other states. There's another company called May Mobility. We also had a company, they have exited the program since, but they were called Easy Mile, was another shuttle company. So these purpose-built shuttles have been a regular part of our program and are treated much like the other companies. Again, they have to report crashes, they have to report disengagements. Again, we are less concerned about the use case and more about the safe operation of the actual technology. So again, my opinions of shuttles is that they're part of the program. They're one of the many use cases that we have. And again, we support really all of those particular use cases, whether it's delivery, whether it's robotaxi, shuttle, and in the future, heavy duty freight transport.
Okay, great. Thank you. Maybe a question about your personal, if you may say, your personal feeling about safety, or based on the data reporting you've been talking about, do you have an impression now that, especially, I guess, the Waymo fleet, do you believe this is much safer than human driving, or it could become much safer than human driving? It's way too early to tell.
Yeah, I think that there's, Waymo has published a lot of data. Everybody can go onto their safety hub. They've done a great job of putting and publishing that and comparing that to the human driver. I think the human driver, the number of miles the human driver drives on the road is so much more, right? So I think the thing that we have to understand is that we're a little early, but currently right now, Waymo is clearly the leader in this space in terms of the number of miles that they're operating, in terms of the number of deployments that they have. And so I think from that perspective, they have demonstrated that they continue to be able to safely operate. Now, again, we really are here just to oversee all of the operation of all of the companies and all that technology. But I don't necessarily want to say one is safer or one is not as safe as the other. Again, we're here just to provide a framework overlooking all of the safe operation of this technology. But clearly, Waymo has produced the most amount of miles in the program here in the state of California, not only from testing, but also deployment. And as you can see, if you go to our website, they've now expanded their operations, not just to San Francisco, Xavier, where you were, but also maybe when you come back to California, you could go down to Los Angeles and see the expansion of their services in Los Angeles as well. So I think the expansion of their services is one indicator of their performance on the roads.
Okay, thank you. There was another question about maybe Pierre, you can elaborate on this. So the AV should recognize a law officer and stop when needed. Is it described in the law enforcement interaction plan, and AV manufacturers describe this?
Yeah, in fact, to get it clear, Miguel, we are discussing with the French government. We are setting up this. I was previously, just to highlight, I was previously at Navia. Maybe you know Navia. Beef is working. Yeah, and today I'm in a PTO, and we are discussing with the French government since 2018 to set up the legal framework. And one question from the law officers that is always an issue we need to highlight is law officer do not care about technology. When he's in front of the vehicle, he moves in his hand like this, and the vehicle should stop, should know that it's a legal officer and it should stop. And we have this discussion how to interact between the autonomous vehicle and the, so I don't know if you tackle this quite deeply. How do you recognize these legal people, and how do you recognize it's an official one, and what is the interaction, etc. So I'm eager to know about it, and if you have document, it would be really great. It would help us.
Yeah, no, this is a very important part, and I will say that as part of the application process, the manufacturers have to describe how they are able to respond to all of those first responders in that particular area. I mean, you can imagine, Pierre, that you have motorcycle police, you have ambulance, you have fire, you have other police type vehicles. How is the ADS going to respond to all of those types of vehicles? Number one. The other thing is sometimes it's just the lights. Sometimes it's the lights and the sirens, right? So we have had situations where we ask the autonomous vehicle manufacturer, how do you respond to hearing just the sirens? Like if you or I were driving on the road and we hear a siren, as a human driver, we're kind of naturally conditioned to look to see where that's coming from. So we engage the manufacturers to understand how does the ADS handle sounds like the sirens, so to speak. You also mentioned hand signals and different types of lighting and vestments, the different vestments that the officers would have. So again, I guess suffice to say that every manufacturer, when they apply, we are going to be individually working with them to understand specifically relative to that operational design domain. It's part of the operational design domain. If they want to be in your particular city, let's say it's your city, what are the various unique attributes and characteristics associated with that city relative to first responders? And so the manufacturer has to describe that. And that's going to vary a little bit from jurisdiction to jurisdiction. But the ADS absolutely has to be able to recognize that.
Thank you.
Okay, thank you. There was a question about Tesla. We know that Tesla has announced, something in Texas, but also they announced that they would deploy the cybercabs in California. So how far are they in the 3 levels of permits?
Yeah, a good question. So Tesla has had a permit to test with a safety driver, I believe, since 2016. So they have held that permit to test with a safety driver, and they have maintained that permit even through today. And so, as I mentioned, if a company wants to deploy robotaxi services or they want to sell a vehicle to the general public, they have to get a deployment authorization. And so Tesla, just like any other original equipment manufacturer, Mercedes-Benz did it, Tesla would have to do the same thing. So Tesla currently has a permit to test with a safety driver. There has been a lot of press about the cybercab, but again, because Tesla is very popular, a lot of people have been following Tesla, but they would have to follow a similar path as any other OEM here in California.
Okay, thank you. I think there were several questions about the better matrix, but you answered partly to that. But Hans, maybe you want to, I don't know if you're still in the call, but maybe you want to elaborate a little bit. What kind of matrix are you expecting regarding these engagements?
Yeah, the point was just your disengagement reports are always really interesting, and I think everyone around the world is following that. You have everyone testing in California, so it's the only place where we can see, compare the numbers, right? So I was wondering if that is something you are planning to build on, working on new metrics, asking for new data from the companies to do these kind of comparisons.
Yeah, it's a great question, Hans. Thanks for the question. So, I'll first and foremost say that the disengagement reports, we don't use the data to compare manufacturer against another manufacturer. I think it's so important to understand that the disengagements are used to evaluate the manufacturer's testing associated with, again, that specific manufacturer. Okay, and the reason being, Hans, is that they're all working on something different. The features that they're developing, it would be difficult, I will say, to compare an ADS manufacturer who's working on a highway driving automation feature versus a manufacturer working on a parking feature or working on a last mile delivery feature. The disengagements would be quite different. Or Pierre mentioned the shuttle companies, right? So the shuttle companies are operating in a much different operational design domain. And so I think the important thing to understand about when you're looking at those disengagement reports is that every one of these manufacturers is doing something different than the others. And so I know when people are looking at the reports, they can say, well, let me take a look at, all of these companies and let me look at the miles per disengagements. But we don't look at it like that. We use the data again to say, okay, how have you addressed these particular issues? You're claiming that you're safe to move into driverless testing or deployment. Let's take a look at your data, your testing information, and see how you have remediated those particular incidents. And yes, we are looking to carry over the disengagement reportings to the new generation of regulations. And I think what we're hoping to see is much more specificity and also standardization in terms of the reporting. If you look at our early reports, you go back to 2015, 2016, really the manufacturer can say a variety of things in those reports. So to your point, Hans, it was very difficult for us to say, well, what is the disengagement? What actually occurred here? So again, just to summarize, we continue to learn and build upon our framework from the past. So really, I would anticipate the new generation of disengagement reporting to be a little bit more standardized, to have some specific categories of what the disengagement is, and to provide a little bit more specificity relative to that disengagement. So again, you'll see some refinements to that reporting mechanism.
Okay, thank you. I think we've covered most of the written questions. Maybe we have, if it's possible for you, Miguel, so 2-3 more questions if some people want to open their mic. Maybe I have a question about, because this is we need to prepare for that in Europe, but I don't think many people realize the efforts from the public administrations to prepare for that. As you said, it started in 2012, and more than 10 years later, you have a department, you have a history about regulating AVs. For a state like California, about 40 million people, how many? What's the size of your department? How many people? And can you give an idea about this?
Yeah, sure. We're still growing. We're still new. In 2018, in fact, we developed a unique team to start working on the policy and regulations. And so I have a team here in California, and it's a relatively small group, but we're continuing to expand and looking to how we continue to build as these companies spread. So yeah, I think the thing is, you're going to have a group that's dedicated to working through this, because if you can imagine, there's interfaces with local governments, federal governments, industry stakeholders, academic stakeholders. There have to be dedicated resources if you're going to build a framework. And that's what we're constructing here in California.
And just to have I mean,
Yeah.
can you tell a number of people?
Yeah, so we have 10 team members on the team, and and again, we're looking to continue to evolve and grow. But yeah, it started off again 2018 really small, and we've slowly been building on the team. And I think the new generation of regulations, when we start bringing in much more data, is going to it's going to enhance and actually require much more robust policy development, and also technical, building out maybe some more technical expertise.
Okay, thank you. Any other question before ending the session? Anyone has it doesn't seem to be the case. So a last remark from Hervé. So Hervé organized a very interesting study tour in China a few months ago, and my colleagues participated. He's organizing a learning expedition in San Francisco during, he's saying in October. So he hopes that he can meet you, but of course we will put you in contact. And I think that's very important that the French ecosystems goes to California as well, and a lot of things to exchange on this. So I don't think it should be an issue. Pierre, you had raised your hand.
Yeah,
maybe for a last question.
Last question, exactly. Miguel, did you tackle? You are tackling the question of robotaxi, of the technology. Did you tackle, or you are tackling the question regarding inclusivity and public transport using autonomous vehicle? Because there are some laws that need to be added, some constraints. Did you tackle this or not yet?
No, that's not something that we have gotten to yet. I think you're bringing up a really good point, Pierre, and that is, as this transportation starts to become more ubiquitous and more available, how do we ensure that all citizens have access,
exactly,
right, to this? And then not just that, but how are citizens who are maybe have mobility issues, maybe be sight impaired, hearing impaired, how are we going to ensure that all of our citizens have access to this? And I think I will say that our charge here at DMV is traffic safety. So we're really dedicated here. I mentioned our team of 10, and we work also in conjunction with our law enforcement highway patrol, as well as other partners. We're dedicated to safe operation on public roads. That is protecting the motoring public, protecting vulnerable road users. But you're absolutely right, Pierre. I think that when you're talking about regulating autonomous technology in your jurisdictions, you're going to have a multifaceted approach to regulations, right? So my charge would be traffic safety, but you may be able to bring in other areas of your government or public framework to focus on public health, mobility, access, equity, all of those things that you just mentioned. And I think that there's an ecosystem of regulators that can come together to address those particular issues, Pierre. And I think that's going to be key, as you mentioned, as this technology starts to become more available.
Thank you.
Very interesting to have this global approach, and I think this is key. Thank you so much, Miguel. That was very interesting as always. Just last question: can we get the presentation and share it with the participants?
Yeah, absolutely. I'll make that available to you, Xavier. I just wanted to say, it's been a pleasure here to speak with everybody. If anybody has any questions, feel free to reach out to me via email. Happy to jump on a virtual call. I wanted to say one final aspect, and that is when we're developing a framework like we have here in California, again, we are balancing innovation and traffic safety. And I think one of the key components of our regulatory process is it's a very public-facing process, meaning that every time we are creating these rules, we invite all stakeholders to come to the table and participate in the formulation of these rules and requirements. So again, it's not going to be any different when we do this again. We're going to be inviting everybody to participate. And I think that that is so important as we move forward, that we have all of the active participation of all of the different stakeholders who are engaged in this space. So again, Xavier, thank you so much for this opportunity, and I hope to talk with you guys soon.
Okay, great. Thank you. Thank you so much, and thank you for attending to the session. Please do not hesitate to drop us a message if you have any question, if we can help you being in contact with someone. So have a great day or a great evening for those in Europe. And thank you, Miguel. And we talk to each other very soon. Bye-bye.